This first is just kind of a picture to show you all the different possibilities. Okay, so in the last unit we talked about here's the area, give me all the possible side or all the possible angles for that particular one, and that was this situation right here. If we're given side B, we don't know where that B is. That B could be out here, or it could be pushed in here. So you can see how it gives me two different angles right there. So there's two different angles at the top, and there's two different angles at the bottom right here. So if we're given side, side, and an angle, we don't necessarily know if there's going to be a triangle or not. Or if we're given side, side, and an angle, that other side across from the angle given might not even be long enough to create a triangle. Or it might be long enough to create a triangle and there's only one triangle. And we're going to be able to figure that out today. That is only when, notice all these pictures are side, side, angle, side, side, angle, side, side, angle, side, side, angle. This is not side, angle, side. You can't skip a side in there. Okay, so you can't call that side, angle, side. If it was side, angle, side, the angle would be in between. Side, we can't skip over to angle and then say side. They have to be next to each other. Okay, next to each other when you say the letters to what they are. So this little chart's kind of helpful to help you figure out when to use law of sines or cosines. Now, you don't have to use this chart. I personally don't think about this chart. I just think about I draw the triangle, what's given, am I given enough to use law of sines, or am I given enough to use law of cosines? Like yesterday, that first problem we did. I think it was 3, 7, and 130 degrees. That was side, angle, side. Well, I don't look at that and say it's side, angle, side, so I have to use law of cosines. I look at that and say I don't have enough information for law of sines, so I don't have a choice but to use law of cosines. There's nothing wrong with memorizing if you're really good at memorizing. Memorize that table, and then you always know what to start with. Okay? If you're given three sides like we did yesterday, you don't have a choice but to start with law of cosines because you don't have enough information in either one of these to use law of sines like we did on the first day. Now, when you're given angle, side, angle, or angle, angle, side, so notice there's two angles given. If there's two angles given, then use law of sines because there's two angles given. One of those is going to be a side, and if it's not the side that we know, we can add and subtract from 180 to find the other angle. So we use law of sines for that. And this last case, SSA, law of sines or law of cosines. We're going to do a little bit of both of those today. Sometimes we're going to use law of sines, sometimes cosines. Because choice 1 and 2, okay, so those are the choices. If you decide to always use law of sines for side, side, angle, and really even more specifically side, side, acute angle. If that angle's not acute and it's obtuse, then we know for sure we either have one or no triangles, okay, because of what we're given. So if the side, side, angle given is obtuse, we're good to solve using law of sines. But if it's side, side, acute is when I would use law of cosines. And then there's even something else in there where you could use law of sines. I'm going to go with choice 2. We're going to do law of cosines. I've done both. I'll be more than happy to show you both ways, and you can pick which way you like. But I'm not going to do them both today because that will be a little lengthy, and you'll get very, very bored. Okay? So you might even get bored to begin with. All right, so solve the triangle. Solve triangle RST. When it says solve the triangle, that means you have to find all the parts that are missing. So the parts that are missing are one side and two angles. So here we have S gives us 126 degrees. It tells us S is 12. It tells us T is 7. I'll say 7 is over here, put a T here. So that means this is R and this is R. Now this is side, side, angle. But because this is already the obtuse angle, our only choices right here, there's no way for there to be another triangle. If one of the angles is already obtuse, that another angle can't be obtuse in that same triangle. So for this one, I would use law of sines because there's no risk. It's side, side, obtuse angle. I'm going to use law of sines to solve that. So I would do just like I did before. sine of 126 degrees over 12 equals, I have to find angle T first. I don't have a choice because I don't know angle R or side R. So I have to say sine of T over 7. That would be your setup. Show your setup, show your work. You don't show that, you're not going to get credit for any of your answer. All right, so if you need to show more than that, I'm going to show a little more than that. You don't have to. If you can do that in your calculator from that point, that's fine. So I cross multiply 12 times sine of T, divide by 12. Then that gives you sine of T. And I'm just going to do that one for you. Now remember, second plus 7, we clear your calculator. It defaults to radians. So you need to be sure to make sure your calculator is in degree mode always. Before you start doing all this work, make sure it's in degree mode. So we have 7 times the sine of 126 divided by 12. That gives us sine of T. We want to know the inverse. So second sine of that value, we get our angle right there, 28.159 degrees. So T equals, there's one part. It gave us 3, so there were 3 parts missing, so we have to find the other parts. Now, we have another angle that was given, so if we add 126 to that number and subtract that from 180, we get our other angle, 25.841. So there's another part. So now all we have left to do is find side R. So that's a setup. A squared plus B squared doesn't work. SOHCAHTOA doesn't work. It's not a right triangle. You cannot use SOHCAHTOA if it is not a right triangle. So we have to use a law of sine or cosine. Since we're finding a side, we found all the angles. Might as well use law of sine. So sine of that side we just found, that 25, and I usually put dot, dot, dot. That just reminds me, don't type 25 in the calculator. Never, never type in rounded answers. Over R equals, I'm going to use the one that's given because I know that's right. So there's your setup. So here's your setup. Here's your setup. Show setup. There it is. Okay, if you need to show more than that, show more than that. 12 times your sine of that 25 number equals R times sine of 126 divide by sine of 126, and then you're going to get your R value. So when you do that in your calculator, you're going to get R equals 6.465. And we do not have units, so that does not need units. We do need degrees on the angles, but the sides do not need units. Be sure you're in degree mode. Be sure if you're going to put that 12 after the 25 number that you close the parentheses. I would suggest putting the numbers in front of the sines and cosines so you don't have to worry about that. Okay, so that was a side-side angle, but it was side-side obtuse. So use law of sines because it's a lot easier, in my opinion. But we could have used law of cosines also. We're going to do plenty of that, so I just want to show you a little bit of both. All right, so here we have triangle. So here's S, oops, which is 40 degrees. The side across from that is 20. Another side is 30, so that makes this R. So that makes this T and this little t. So here we do have a side-side acute angle. So I'm going to choose to use law of cosines because when I do this in law of cosines, I'm going to put in the calculator and I'll show you and tell you in a second how the calculator is going to help. But first I'm going to do the setup for law of cosines and then show you what to do with that. All right, so if I'm going to use law of cosines, I have to take this side right here. And again, the reason why side-side acute angle is the ambiguous case, because if this is our 40-degree angle right here, that 20, so this is 30. Our 20 could have gone out like that. This could be 20, and this could be 30. We don't know what that triangle is right there. This is still S, this is still R, this is still T. This 20 could have come in like this to the left, or it could have been flipped out to the right. It's still 20, and so now look at those angles. They've all changed. So that's why we have this ambiguous case with side-side angle, because we don't know. Just because we drew a triangle a certain way doesn't mean that's it. All right, so regardless of how I drew my triangle, the side across from the only angle that I was given is 20. So that's 20 squared equals 30 squared plus t squared, or t squared plus 30 squared. 1 plus 2, 2 plus 1 still gives you 3. Doesn't matter the order that you add. Minus 2 times 30 times t times the cosine of the angle across from the side that I used. I'm always equaling that to the side. So if I just look at this and look at my variables, we haven't come into this problem yet. We have a squared and an unsquared. So a t squared and a t, if we think about that logically, that's going to give us a parabola. Okay, so we don't know what it looks like. We've never had a cosine in a parabola, but cosine of 40 is just some number. So this is t times some number. T squared is positive t squared, so that's a parabola that faces up, and it equals 20 squared. Now, solving parabolas are usually easier when you set it equal to 0, because you're using a calculator. You don't have to. You could set it equal to 400, but then your window is going to be all the way up to 400. So the best thing to do, what I would do, is bring that 20 over. Now, the 20 squared, that's 400. The 30 squared, that's 900. So if I subtract 400, I can write 500, or I can write 30 squared minus 20 squared, whatever you want to do. But I'm going to say 0 equals, if you want to leave it 30 squared, and I'm going to put the 30 squared and the 20 squared together, doesn't matter where you put it, the beginning, the end, minus 20 squared, or 900 minus 400 gave us that 500. Either will work. You don't have to do all that math because the calculator will do it for you. Minus 2, plus t squared minus 2 times 30 times t times cosine of 40 degrees. So what I can do now is put this in y1. I want to know, when does y1 equal y2? So we're going to have a horizontal line at 0, and we're going to have a parabola that faces up. And this is where the parabola can either, all that we care about are the positive numbers, right? The side of a triangle can't be negative, so who cares where it crosses on the negative side? There's 3 options here. Either the parabola is going to cross the positive x-axis twice, it's going to cross it once, or it's not going to cross it at all. And this is our ambiguous case where we have a chance of 2 or 1 or no triangles. We don't know. We could have both of these, we could just have one of them, or we might not have either one of them. That 20 might not even be long enough to reach up to that side right there. We don't know if that works or not, but the calculator is going to tell us. So when we go to y equals, right here, doesn't matter if you put 0 in y1 or y2 or y10, whatever y you want to put it in. And then I'm just going to do 30 squared. 30 squared minus 20 squared, or 500, that's fine. 900 minus 400 is 500, plus, I need a variable, x squared minus 2. I'm just typing in exactly how I have it written right there. Parenthesis, 30, close, open, x, close, open, cosine 40, close, close. And at the end, if you put that minus 20 squared at the end, it would be very important to close that 40 right there. Okay, if you're not putting it at the end, whether you close it or not, it doesn't matter because there's nothing else there. All right, so we're going to graph it. There's your y equals 0. that should show up. If you don't have a color calculator, then you can make it bold. You can go to y equals, second y equals, and go over to the left and make it a little bit bolder so you can see it a little bit easier. And the parabola is not on there, but those numbers are huge over there. So what I do is I zoom 0 will get me started. It'll at least get me on the right path, so I can at least see the picture. Yes? Nope. You can use law of sines. You can use the quadratic formula. All kinds of different things you want to do. Okay? All right, so I need to see further to the right. So window, I'm going to make that 50. Just see what happens. And now I can see it dips down and come back. I can't, this is a 0, so I really want to see a little bit further down. So I want to make my y min, I don't know, -200, because I want to see below it. So now I can just see a little bit better. If you want to make your y maximum not so big, because we don't have to see to 1,000, make it 200. See it a little bit better if you want to. You don't have to. Again, whatever you want to do right there. But we can clearly see that it crosses the positive x-axis twice. That tells us right there we have 2 triangles. So we have to do all of this for 2 triangles. This is going to be, and what are we even solving for? Like, what are we even doing? Well, we put this in. So what do we do when we solve using graphing? We're solving for t. Little t. That's the side. So we have 2 sides here, and we need to do them individually because the calculator can only store one thing at a time. Now, it can store a bunch of different letters if you want to change it. But when we find this point of intersection, second trace 5, enter, 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 it gives us one of those. And the calculator has automatically stored x as this and y as this. Y doesn't matter right now. If it ever did, it is stored as that right now. But we're going to have to use that value right there. So 17.676. There we got a value. So that's our first triangle. T1, 17.676. We're going to have a T2, but I don't want to solve that yet because then it's going to get rid of my T1. And I need to use that T1 in order to find my angle T1. And then I'm going to need angle T1 to find angle R1. Because then over here I'm going to have angle T2 and angle R2. So I have to have a setup. Law of sines or cosines? Because T1 is 17, which is the smallest of all the sides, we know T1 is for sure acute. So therefore, sine of T1 over that 17 number equals sine of 40 over 20. So we cross multiply that 17 number that we just found. Now, I said that was stored, so if I go to my screen right here and I just type in x, it's stored. Every time you find an intersection, it automatically stores it, or a 0. Never. You don't ever have to draw 2. I just did it so you could see. No, you have to find them. You don't have to draw. Now, solving is different than drawing. If you have to draw 2 triangles, no, you never have to draw them. But we already figured there's 2, so I have to solve both of them. I don't have to. And the other one's all wrong. So don't do that. We know, for a fact, there are 2 triangles. Nope, you'll get 2. I'll talk about that. And that's, so you got to read, if you look at choice 1, you got to read choice 1 on the front side of that, how you would do it using law of sines. Law of sines will only give you an acute angle. So you got to be able to figure out, how do I know if there's 2 triangles or not? Well, you have to read, if you look at choice 1, right here, okay, law of sines, sine will only give you the acute angle, okay? So you have to find both measurements for the same angle using law of sines, but the calculator will only give you one answer. So you have to find the other by subtracting from 180. But you have to be sure and subtract the correct angle from 180. Which one is it? Is 180. It's the one across from the side that was given. So there's a little bit more involved in law of sines, then use law of cosines, look at the calculator, does it cross the positive axis twice, once, or not at all? And then you know for sure your answer. Whereas law of sines, you have to be a little bit more aware of what is happening. But either one will work. Again, I'm choosing to use law of cosines, but if you choose to use law of sines, you just have to be aware of that. You've got to figure out, is there another triangle or not? And remember which angle adds up to 180. Which one does, which one doesn't. All right, so when we do this right here, what are we doing? Sine of 17 times sine of 40. So that 17 number times sine of 40. And then we are dividing by 20. Divided by 20. And then we are taking the inverse sine of that value, which gives us our t, 34.619. So 34.619 degrees. Now we have two of the two angles. So two of the three. Add the one that was given. Subtract from 180. And you have your third angle, 105.381 degrees. And there's one triangle. Now we got to do all that again for the other triangle. All right, so this is how we knew there were two triangles. When I went to my graph, it crossed twice. It meaning the graph. This graph crossed once. This graph crossed twice. That tells me. So how do I know if there's 1, 2, or no triangles? When I graph the parabola, it will cross the positive x-axis twice. That's two triangles. It will cross the positive x-axis once. That is one triangle. It will cross the positive x-axis not at all. No triangle. That's how you know. Okay? That is how we know. When we look at this graph, it crossed twice. So that means we've got to do it for each number. We can't pick the one we like best. Okay? We've got to do them both. So, second, what? It, meaning the red, the graph, the parabola, has crossed when it came down, and it's crossed when it came up. Is it negative? So, x is not negative to the right of the x-axis. Here's x equals 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever, right? So, here's an x value that's positive. If we keep going to the right, x keeps getting bigger. So it's still positive. So now we got to do everything for that number. Because we got to go back to algebra 1. How do we solve a quadratic? By graphing. We graph it, where does it cross the x-axis? Those are our solutions. We are finding our solutions for the variable. The variable in this problem was t. T, when I look at my picture, little t is the sides right here. So I've got to find both of those t's. So, second trace 5. Now, if I just said enter, 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 it's going to keep taking me to the same one. I have to go get closer to my other point. Doesn't matter if you're on it. We're on the red graph, the blue graph. I can be way over here. I'm closer to the other point of intersection. Enter, enter, enter. There's my other t value. X is in the calculator, t was on our paper, so it gave us two t values. It crossed twice. So 28.286 is my other value. This was a quadratic t squared. T, that's a quadratic, which produces a parabola. Parabolas can either cross the x-axis here twice. It can cross once, touch. It can not cross at all, but we're dealing with triangles which only have positive sides, so we don't care if it crosses in the negative. That's not a solution. Right, so can a side of a triangle be negative 10? No, can't be negative 10. We are actually solving a triangle. A triangle cannot be negative. We cannot have a negative angle. We cannot have a negative side. So the positive. Does the parabola cross the positive x-axis twice? Does it cross the positive x-axis once? or does it cross the positive x-axis? Not at all. Those are your three options for 1, 2, or no triangles. Okay? Now that we found this, now if I go to my blank screen, x is stored as something else now. Now it's stored as 28 because every time you redo it, that's why I couldn't find both those at the same time. Then I have to go back and find the other intersection again because every time you do something, it's going to store it as something else. Every time you find an intersection of 0, you store it as something, it's going to change its value. So now we have another setup that we must show, and that's going to be for this right here. So sine of angle T2, there's no risk. 28 is smaller than 30, so there's no way the side T can be an obtuse angle. 30 is the biggest side. 28 is smaller than 30, which means there's no risk in angle T2 being obtuse. And we use that 28 number equals sine of 40 degrees over 20. Nothing. It's stored. It is stored. Once I find an intersect, it's stored. You don't do nothing. There's nothing to do. It's stored as x, the y is stored as y. Every time you do an intersect, it restores it as whatever you found it to be. Okay, that's why we can't do them both at the same time and then store them. Or you could store it. I mean, you could find the first one, store it as something other than x, store it as a. Now you have that one stored as a, and then the next one stored as x, and then change it to whatever letter you want. But it's going to change. Every time you do something else, it's going to change what x is. So here we have that 28 times sine of 40 equals divided by 20 equals the inverse sine of that is 65.381 degrees. Don't forget your degree symbol. And with that original, we had plus 40 equals, subtract from 180, 74.619. And there are all of your answers. If you miss one of those, that is half the problem. Okay, you have to be very careful on these. When it is side-side acute angle, there is a chance that you have two triangles, one triangle, or no triangles. If you set up your law of cosines, and now if we had left it, again, we could put this in y1 and this in y2 and see where it crosses at 400, but all we care about are the positive. We don't care about x being negative because it's an actual triangle. We can't have negative sides or angles. Now, if we had used law of sines on this one, what would we have had to find first? On this triangle, if we chose the other option, option 1, then we would have had to find angle R first, right? Because that's the only information we have. We couldn't have found T, because angle T and side T are both missing. So we would have had to find angle R first. That's the angle that adds up to be 180 degrees. So what you would have done then is you found your R. It only gives you 74. You would have had to subtract from 180 to get your 105, and then work backwards from there, which is fine. That works. If you want me to go over that in more detail with you, I'll be more than happy to do that. When we're working on our homework, before school, after school, whenever you want to do that. Okay, but that is possible. What happens is, a lot of times you just do both angles. So now you have a triangle that's like 250 degrees, and that can't happen because you don't know which angle. Well, how do I know which one adds up to 180? Well, you have to know that. If you're going to use law of sines, you have to know the two angles that add up to 180 are always going to be the ones across from the side that was given. Always. And that works just fine. Law of sines setup. Law of cosines, you don't have to think quite as much, because once you plug it in, you just look and see. Does it cross the positive x-axis, by it, the parabola, twice, once, or not at all? All right, so here we have angle C is 42 degrees. Side C is 70. A is 122 down here, so then this is T. So that's T. So side acute angle. Side acute angle. So there's possibility of that 20 being out like that. We don't know what it looks like. This could be 122 and 70. That's 70 going out like that. And that's our 42-degree angle. We don't know which one it is. You do not have to draw, you can just draw a triangle, whatever it looks like. You do not have to draw two, you just have to be aware. Side acute angle, ambiguous case. Maybe one, maybe two, maybe none. So if I set up my law of cosines, 70 squared equals T squared plus 122 squared, or vice versa, it doesn't matter, you're adding, doesn't matter what order you add in. 2 times T times 122 times cosine of 42 degrees. Now this 70 squared is together, so if I subtract 70 squared over here, I am subtracting 70 squared from that side, and I can put it wherever I want, okay? Doesn't matter where I put it. I'm going to put it on the end this time, just so you can see what it looks like. We already have our 0. 0 equals all of that right there. So I'm going to clear that out. And I'm going to say x squared plus 122 squared minus 2 times x. Again, I don't have to have those parentheses. 122. Don't use a negative sign. Minus. Okay, minus means subtract. Negative means you're multiplying. That 122 squared times that, and you're not going to get the right answer. Cosine 42, close. And then I'm going to subtract that 70 squared at the end. If I decide to put that at the end, you have to close this right here. Okay, you have to close that right there, because if not, that 70 squared is in there, and now you're taking the cosine of whatever 42 minus 70 squared is. All right, maybe we're on that whatever screen, maybe that screen works, maybe it doesn't. I always hit zoom 6, that gets you back to standard. There's our y equals 0. And then I hit zoom 0 to at least get me started. So I can see it's a lot higher, so I'm going to go a lot further over on my window to see what happens. I don't know, 200. Graphic. Doesn't cross the x-axis at all. So there is no triangle. The directions will probably say, solve the triangle. If there is no triangle, say no triangle. Follow the directions. Do what it says. Now, you're solving, and I said, if it says solve, no solution is appropriate. Would no solution be appropriate? Yes, because we said solve. But if the directions say, write no triangle, then do what it says. It's telling you exactly what to do. So there is no risk in getting any points off if you write the exact words that are on the directions. If you write something else, it might be right, it might not be right. You don't know. There's a chance you could get points off, or there's a chance you write something that doesn't even make sense. Invalid. Okay, what is that? That is not even a word that I've ever written down or said as an answer. Something, I don't know, there's some other crazy word written. Write the words that we use. Then you don't have to worry about getting points taken off. Don't write words other people tell you to use unless they're grading your tests and quizzes. We are grading your tests and quizzes. We will tell you the words to use that you will get 100% correct. And you can't just write no triangle without any work. That's going to be all wrong. You have to have some kind of setup to prove that you have no triangle right there. Whether it's law of sines or cosines, however you choose to do it. All right, so here, again, law of sines or cosines, it's up to you how you want to do this one. Here's C, that's 4, A is 3. So, side acute angle. But what do I know about angle A? What does it have to be? Acute, right? Because it has to be, we know for sure it is smaller than 53. We don't know how small, but we know it has to be smaller than 53. So is there any way for A to be obtuse and acute? And that's the angle that would be the one that adds up to 180, but that's not possible. So if you recognize that, then you could use law of sines right here. I'm going to do law of cosines just so you can see, like if you're like, I'm always going to use law of cosines, that's what I can do. But we know for sure this is either one triangle or none, because there's no way for that angle A to be acute and obtuse, because we know it's acute, and if we subtract from 180, that's going to give us the obtuse angle, and that's not possible. But I'm going to show you what it looks like on your calculator if you choose to use law of cosines. So if I choose to use law of cosines, 4 squared equals, now we have b squared plus 3 squared so there would be your setup. If we subtract, 16 might be easier. That squared kind of throws people off sometimes. Subtract 16. You can even combine those together right there. The 9 and 16. I'm not going to rewrite it. You can see all that rewritten. But again, in our calculator, we're going to go to y equals. We already have a 0 there. I'm going to say x squared plus 3 squared. I'm just going to say the minus 16 right there, or minus 4 squared. You can put it wherever you want, beginning or the end. Minus 2 times x times 3 times cosine of 53. Now, very important also, this cosine word right here. I was doing a problem yesterday, and I accidentally put the word sine there. Okay, it is very easy to do. Very, very easy to do. So don't rush through these. Be very careful, especially when we start the next sections. We're going to add in that area of a triangle again, which does use half side times sine of included angle. So very, very important to get your words right, because making that sign is going to make it close, but not quite the right answer. So when I graph that again, I'm on that crazy screen, so I'm going to zoom standard, which is zoom 6, and this is that situation. I can't have a negative length of a side, so I don't care about that intersection. All I care about is this one. So if you're using law of cosine, this is what the graph looks like. And so I only care about that positive one. So that means there's only one triangle here. It was the ambiguous case, side acute angle. But because the parabola only crossed the x-axis 0 once, that's why we only have one answer. And we get 5.009. So B equals 5.009. Then we have angle B, and we have angle A. Now, you want to be careful right here. Side B is the biggest side. So we cannot use law, well we can, but we do not want to use law of sines to find side B, because there's a chance that it's obtuse. There is a chance. Since side B is the biggest side, we cannot use law of sines to find B. It might or might not. If it happens to be acute, then we happen to get the right answer. If it happens to be obtuse, then we get the wrong answer, because law of sines will not give you an obtuse angle. So our setup has to be to find angle A first, and then subtract to find angle B. So 3 times sine of 53 degrees divided by 4. Take the inverse of that. You get your angle A to be 36.797 degrees. When you add that to 53 and subtract from 180, you do get an obtuse angle. Barely, but barely is still obtuse. If you had tried to use law of sines, will it give you an answer? Absolutely, it'll give you an answer, like 89 degrees. That's not right. It's not. There's not another answer. There is only one triangle for this situation. So, ambiguous case,